Welcome back to J Squared Manufacturing Design. We're still working on this first injection mold. Right now we're talking about putting in the gate location because that's something that's fixed and will affect our water line placement and other features of the block. So one thing is we always want the gate location, well, not always. We often want the gate location to be on the B side of the part because of ejection issues as well as cosmetic reasons. So the cosmetic side of the part is generally on the A half of the mold, or the cavity block, as I call it in this split here, cavity block, where this is the cosmetic surface. We don't really want to put a gate blemish right here on this cosmetic surface. We could, if the customer wanted us to. That would actually be almost an easier place to put a gate, but we don't have to. In order to put them on the core, we want to gate, we could do an edge gate, which would put it on the cavity and leave a blemish on the side. What my thought is to do a cashew gate or a sub gate and gate right on this face right here. So what we'll use is this, let me see if I can find this PCS sub gate part. We're not looking for thermoplastic elastomers, we're looking for standard plastic. So now we want probably a square. No, then we have to wire the pocket. Let's go with the round. Thought there was more. It's been a while since I've used these, so let's see here. Shot weight in grams. Let's find that out. Let's go back to our SolidWorks part. Kind of the nice thing about SolidWorks is you can switch between units. Without affecting much. In CREO, for some reason, sometimes it can cause things to fail when you switch between units. So this is 20 grams, roughly. So this says we need a TGR 10 MB. So let's see here. So a TGR 10 1 2, this one right here. So let us CAD files step, go in folder. Alright. We're just going to drag and drop this into our window, open it up. Alright. here we have a little surface here where we can make a gate vestige into the part. So let's go ahead and do that. Let's actually create a plane on here and fill and project. We're not real concerned with how big this oh, come on, is it not going to let me solidify that? Oh. There we go. Alright. Now let's see how this fits in here. So, analysis measure. I don't know why this calculator is. We won't use a calculator, we'll use snipping tool. Oh. Okay. So now then, back into our core, and let's gate it slightly off center. I don't have a mold flow, I'm just kind of going based on this, filling this corner back in here. And I want to do a little bit of an offset so I can get rid of the cold slug. So let's just do a sketch on this plane. And then do point here and a point here. We're not going to go that far off, we're going to go a quarter inch off. Now, we do need to mind our diameter. Ah, damn it. They didn't copy it for me. There we go. So now we can just kind of drag these in here. And we want to make sure that we're getting about right there. 0.840. 5. So there we go. Now we're going to put a hole in that diameter 0.866142 in depth, flat bottom, pattern, point. Okay. Now you see we have a slight problem. If you look at these, they're made to be held in by a bolt from the back. An M5 bolt from the back. So we actually need to make our insert thicker to be able to use these in the proper fashion. So right now we have a paper thin wall there, and that won't work. So what we'll do is we'll go in to our split, edit our workpiece, and we'll make this 1.375. There we go. Now, since we did that, we change these plus 0.1375. There we go. Now we maintain our bearing surface. That bearing surface looks a little much. We won't worry about it right now though. Could always fix that later. So now we have our gate locations sorted out. Now there's a problem though, I guess I forgot. We still do need to orient these. So you can see there's a flat on them. Now, the way they're intended to be oriented is with a dowel. So what we'll do, let's look at this model real quick. There it is right there. Dowel location. So that is going to be done we'll do that whenever we assemble it, because I want to make sure I get that in the right spot. So we won't worry about that for right now. We'll just keep everything away from that area. So now we can route our water, which is probably the next most important thing in this block. It's fairly small block. We can probably go with one circuit if we can figure out how to snake it back and forth. So let's see here. Zero corner is going to be up here. So we want to exit over here. So if I go in, let's do this, I guess. So, locations, mold cast, water line, 0.438, nah, 328, make datum, offset, can't read inner value. Negative 0.75. Done. Top. Sketch view. Alright, so we're going to have in right here. And then we're going to come across. Out right here. Across. Now I need to get back and back as evenly as possible. Keeping in mind that there's really no reason to cool this right here. So probably our best bet is to throw the needle on those. You can see our water line shown up there. We don't want it to be that close to other features. So that's probably as even as we're going to get there. And then this line is going to be somewhat of a problem. We actually won't put it in. So we're going from 0.25 to 2.344. I would really like to have some water on that side though. You know what we're going to do? We're going to do 2 circuits. And they're going to come out opposite sides of the mold, which is not really a big deal. We're going to have one come out here and another one come out here. And they'll be joined right here. So this will need to go in. You can see we're hitting our point there, so let's make that 4.25, too far. 4.125, still too far. 4, close it up. 4. How does that make those look? Okay. 5. Now we'll actually need to make these exit the block. And you can see these don't connect. The reason why these don't connect is that this is a planar waterline feature, so it will only do water lines on this one plane, and I need these to be on a different plane so I can cross this without interrupting this line. So we go in, out, or in, over right here, not back here, over, out, over, around, in. So we're going to confirm this. Okay. Now we can't see anything, so it's kind of confusing. So what we're going to do is we're going to go to view. First of all, we're going to change the block color in general. And down here you'll see it says, oh, I can't. Down here at the bottom it says, right there in front, it says housingcore.prt. That's what we want. So we want to select on that, center mouse. That colors the whole part, and every feature inside that part will be colored that color. Now we add some transparency. Grab these faces. Now we can see our water lines. Now what I want to do is, first of all, those are too far away. So edit 0.75, make it 0.5. That's better. Now I'll come in here with a hole and analysis. I'm going to make those 0.328. Now I want to grab this axis and that 0, and I want to be above that, so I want to be like 0.5. That may be too close to the edge of the block, but it looks like it's okay. So then we'll just bring this over. We want to go past to 4.125, and we want to make it a standard. There we go. Now that is going to be the same on both sides, but we're not done yet. So we need to do a hole from the back to connect these. We're going to put it on those axes so it's connecting the two. And then we're just going to bring it just past 1 inch standard. We're going to copy that, paste it here. Do. Perfect. Now, since those should be the same, should be able to mirror. What's it? Okay, that mirror failed. So let me. I didn't mean to mirror copy the. So I'll just copy the hole and paste it. And there I've got all my water. And for transparency, we will color these water lines so now we can see that we have water circuits that go in, around, up, down, and out. And they are close to our other features, but it's manageable. That one could be a little bit further away. This one looks like it's pretty close too. 175. It's not really measuring the right thing. 125. Depends on who the mold maker is, if they're going to be comfortable with that. Personally, I'd probably drill it that way. This small of a block, you're not going to have that much walk in your drill bits. So, as long as you take it slow. So, at least for now, we'll leave it until we'll be talking with a mold builder. We discuss it and make sure it was okay with their process. Like I said, it depends on the mold builder. I've had it either way. But, okay. Well, looks like that's it for this video. In the next video, we will finish up this insert, put in the rest of the ejector pins, put in the runner and gate system as well as the screw pillar pins, and the pins to eject the cashew gates, and which that may be a problem with our water. We may have to move our water. I think I have an idea. Too close, those overlap. I may have to change how so then what I'll do is I'll come in, So this way I have room for an ejector pin right here, or in theory I do. And I can come in like oh, I can come in like this, capture my water line, and avoid those being too close together. And there we go. So, ejector pins, screw filler pins. Screw filler will now be a problem. Yeah, we're gonna have to make this block wider and move these parts apart. There's no ifs, ands, or buts about it. So we'll adjust that. That's the thing about, like, you can't just split something and be ready to be done with it. You're gonna have adjustments. You're gonna do the best you can, and sometimes, like in this one, I'm saying that my machine is unlimited. In other cases, you may be limited by your machine, and there may have to be compromises on water to get what you need to get. So I'm making other considerations that may not be what you would make if you were actually designing this mold. So, and actually, when we come back, I may redesign this water completely because I see what may be a better way to do it, and I didn't see it before. So we will most likely be completely redesigning this water for a better outcome. Yes, we will be. So this is the process of designing mold. Not everything works out the first time. You gotta adjust, you gotta pivot and rework. So, see you next time.